What's up, guys? In this video, I'm gonna explain how to graph quadratic functions in Vertex form. So, let's say we're given with a quadratic function in the form y equals a times x minus h squared plus k. So that's in Vertex form. How do we graph the quadratic function? Alright, in order to graph, we have to study or discuss one by one all of these key features because all of these are important to graph the parabola or the quadratic function. Okay, let's begin with the variable a. What's variable a? Well, variable a describes the opening of the quadratic function. It describes if the quadratic function opens up or opens down. If a is positive or a greater than 0, it means it is opening upwards like this. Now, if a is less than 0 or negative, it means it is opening down like that. Okay, next, the vertex point. So the vertex point is either the highest point or the lowest point of the parabola. It depends. If your a is greater than 0 like this, opening up, then your vertex is the lowest point. Okay? Now, if your parabola opens downward, the vertex is the highest point. The coordinates of the vertex are h and k. H is the x and k is the y coordinate. H and k are easily identifiable in our vertex form equation. That's why it is called vertex form because you can easily spot the vertex, HK. Alright? Now, the axis of symmetry is the vertical line x equal to h, this one. Axis of symmetry divides or cuts the parabola into two equal identical halves. So, if you cut this like that, this part is identical to this one. So, this one acts like a mirror. Now, for domain and range, and the maximum and minimum we will discuss later on. So, without further ado, let's begin with some example problems. Let's begin with this equation. Say we have to graph y is equal to x plus 2 squared minus 3. Alright, this is in vertex form, quadratic function in vertex form. I'm gonna rewrite y is equal to, because we want this to be minus. So x minus negative 2. And also, we want this to be plus. So plus negative 3. Okay? Now, this is in the form of y is equal to a times x minus h squared and then plus k. Let's identify all of the key features one by one. Let's begin with the variable a. Variable a here is 1, right here. So 1, and we know that 1 is greater than 0. It means our quadratic function opens up. Alright? Next. What is our vertex? Vertex has the coordinates h and k. Therefore, our vertex point is, so h is negative 2, while k is negative 3. Next, what is our axis of symmetry? The formula for axis of symmetry is x is equal to h. And we know that this is h, this is k. This is h, this is k. Therefore, axis is x is equal to negative 2. Next thing here is we have to find a set of ordered pairs to which this quadratic function passes through. Alright? Passes through. So, I'm gonna assign x values. Say, for example, x is equal to 0. Avoid assigning the axis of symmetry because that's the vertex point. Okay? So, say x is equal to 0. Let's substitute this x equal to 0 to our quadratic function. Y is equal to x is 0, and then continue. Plus 2 squared minus 3, y is equal to 0 plus 2 is 2 squared minus 3. 2 squared is equal to 4, and 4 minus 3 is equal to 1. Therefore, one of the ordered pairs or one of the points to which this quadratic function passes through is the point 0, 1. X is 0, y is 1. That's right here. X is 0, y is 1. Let's assign another x value. Say x is equal to -4. Let's substitute to this equation. Y is equal to x. X is -4. And then plus 2 squared minus 3. Let's simplify. Y is equal to -4 plus 2 is -2. And -2 squared right here is +4. And again, 4 minus 3 is equal to 1, which means another point on this quadratic function or on this graph is the point -4, 1. X -4, y is 1. All right, this is enough. Okay, we can now graph having these 2 points and the vertex point. Okay, now, if you notice, I assigned x equal to 0 earlier and then x equal to -4. I make sure that these two x coordinates are on the opposite sides of the vertex. Our vertex, the x coordinate is -2. So I assign a value that's greater than -2, so it means to the right, and I assign a value that's less than -2, which is -4. All right, assuming this is our coordinate plane system, let's begin graphing. Our vertex is the point -2, -3. So that point is right here, -2, -3. We call this vertex point -2, -3. And then we will also graph or plot these 2 points. 0, 1, x is 0, y is 1. So that point is right here. And also, x is -4, y is 1. So somewhere around here. And as you can see, we can now graph our parabola. All right, so this is our parabola and it confirms that the parabola or the quadratic function opens up because a is equal to 1, which is greater than 0. And also, our axis of symmetry is x equal to -2. So where's that? This is the axis of symmetry. And as you can see, it divides the parabola into 2 equal parts. So x is equal to -2. It passes through the x coordinate of the vertex. Now let us discuss the domain and range. First, what is the domain? Domain is the set of all x values. And for all quadratic functions, either opening up or down, it doesn't matter. The domain is the set of all real numbers. What does it mean? It means there's no restriction in our horizontal direction. Okay, so it means the function exists no matter what the value of x is. Because as you can see, it opens up infinitely and they will spread out apart as the graph goes along. So it means the function exists infinitely to the left and to the right. Also, we can rewrite this. We can say that the domain is from -infinity to +infinity. All right, again, looking horizontally, the quadratic function exists from -infinity coming from the left to +infinity to the right. How about the range? Range is the set of all y values. And unlike the domain, where there's no restriction, there's restriction for the range because we have our vertex point. So basically, vertex point restrict the vertical values of the function. For example, in this graph, as you can see, this vertex point is the lowest point since our parabola opens up. So it means the function is not defined lower than this vertex point vertically. All right? Again, for the range, we're looking vertically. Okay, so the function exists from this vertex point, from -3, the value of y, going upwards. So we can say that the range is y is greater than or equal to the y value -3. Or we can say that the range is from negative 3 up to positive infinity. And lastly, we go to the maximum and minimum. What is our maximum? Well, for quadratic functions, you cannot have both maximum and minimum. If there's a max, there's no minimum. And if there's no max, there's a minimum. So for this quadratic function, our vertex is the lowest point since the parabola opens up, which means there is no maximum value. Our quadratic function will continue to exist upwards infinitely. So we're going to say D and E. D and E or NA. D and E stands for do not exist and NA stands for not applicable. While for the minimum, we have a minimum. The minimum of this quadratic function is the vertex point, which is negative 3. Not x, because maximum and minimum refers to the value of the function. So we're referring to the y value. Okay? So maximum y or minimum y. And in this case, the minimum y is negative 3. Next, let us try to graph the following quadratic function. Y is equal to negative 1/4 times x plus 2 squared plus 5. All right, let us rewrite. Y is equal to negative 1/4 times x and then minus negative 2 squared and then plus 5. This is in the form of y is equal to a times x minus h squared plus k. Let us write now all of the key features. First, the variable a. Variable a is 1/4, or rather negative 1/4. And since that is negative, it means less than 0. And it also suggests that our parabola opens downward. Next, what is the vertex point? The vertex point has the coordinates h and k. So 2, rather negative 2 and 5. Negative 2 and 5. Next, the axis of symmetry is the vertical line x is equal to h, and our h is negative 2. So let's write negative 2. Next, we have to find other set of points to which this quadratic function passes through. So we will assign x values. Take note, our axis is negative 2. So I'm going to assign an x value that's lesser than this and greater than this. Say x is equal to 0. I assign an x value that's greater than negative 2. 0 is greater than negative 2. So let us substitute this to our quadratic function. Y is equal to negative 1/4 times x equal to 0, plus 2 squared plus 5. Y is equal to negative 1/4. 0 plus 2 is 2 squared plus 5. Let's proceed. Negative 1/4. 2 squared is 4 plus 5. And then negative 1/4 times 4, that is negative 1. And negative 1 plus 5 is positive 4. This means one point along the graph of this quadratic function is the point 0, 4. x0, y is 4. It's right here. 0, 4. Next, I'm going to assign, say, x is equal to negative 4. A value less than our x-coordinate of the vertex. So let us substitute this one to our equation. Y is equal to negative 1/4 times x is negative 4. And then plus 2, copy, plus 5. Y is equal to negative 1/4. And then negative 4 plus 2 is negative 2. And negative 2 squared right here is equal to positive 4. So negative 1/4 times 4, again, plus 5, Negative 1, 4 times 4 is negative 1. Negative 1 plus 5 is equal to positive 4 again. Therefore, another point along the graph is negative 4, 4. Negative 4, 4. Okay, assuming this is our coordinate plane system, let's plot first the vertex point. Negative 2, 5. So negative 2, 5, somewhere around here. Okay, negative 2, 5, vertex point. Next, let's plot these 2 points that we have assigned earlier. 0, 4. So when x 0, y is 4. And then negative 4 and 4. Negative 4, 4. Now we can trace our quadratic function. So our quadratic function opens down, and this confirms that our a is indeed negative, opening downwards. Also, our axis of symmetry is x is equal to negative 2, the vertical line that passes through our vertex. Next, let us find the domain. Again, the domain of all quadratic functions is the set of all real numbers, or from negative infinity up to positive infinity. Next, what is the range? Our quadratic function opens down, so we have a maximum point at the vertex. So it means the function exists from this vertex downwards. So the range is y should be less than or equal to the y value of the vertex, 5. Or we can say that from negative infinity up to 5. We're looking vertically, okay? We're talking about range. So from negative infinity up to positive 5 with a bracket, because 5 is included. And lastly, what is our maximum value? The maximum value is 5, the vertex point. Our vertex point is the maximum point since our parabola opens down. And since we have a maximum, what's our minimum? Minimum do not exist or not applicable. Let us try one more. Say we have to graph the quadratic function y is equal to 2 times x minus 3 squared plus 2. This quadratic function is in vertex form y equals a times x minus h squared plus k. Let us now write one by one all of the important or key features. Let's begin with the variable a. The value of a is equal to 2. And since 2 is greater than 0, it means our parabola opens upward. Next, what is our vertex point? Vertex point has the coordinates hk. So, h is 3, k is 2. So 3, 2. Next, the axis of symmetry is the vertical line that passes through our vertex. So x is equal to h, and h is 3. Next, we have to assign x values to determine some of the points along the graph. So passes through. So let's say x is 2. If x is equal to 2, let us substitute here. Y is equal to 2 times x is equal to 2. Minus 3 squared, and then plus 2. Let's simplify. 2 times 2 minus 3 is negative 1 squared plus 2. Negative 1 squared is 1. 2 times 1 is 2, plus 2 is 4. So y is equal to 4, which means one of the points along the line or along the graph is the point 2, 4. When x is 2, y is 4. How about, let's say x is equal to 4. So y is equal to 2 times x is 4 minus 3 squared plus 2. 4 minus 3 is 1. Okay, so 1 squared plus 2. Again, 1 squared is 1. 2 times 1 is 2. And then 2 plus 2 is 4. Y is equal to 4. So another point along the graph is the point 4 and 4. That's right here. 2 and 4. And then 4 and 4. Now we can begin graphing. Let's say this is our coordinate plane system. Let us plot first the vertex point 3, 2. So x3, y2. So around here. This is our vertex point 3, 2. Next, let us plot the points 2, 4, 2 and 4 right here. And the point 4 and 4. Now we can graph our quadratic function. This is the graph of our quadratic function given. And as you can see, our parabola opens up and it confirms what we have predicted earlier. A is positive, so opens upward. Also, our axis of symmetry is the vertical line x is equal to 3, and it divides our quadratic function into two identical halves. Next, let's write the domain and range. You know the domain is just the set of all real numbers because there's no restriction, or from negative infinity up to infinity. Again, there's no restriction horizontally. The quadratic function exists both to the left and to the right. Now, the bigger question here is the range. What is the range of our quadratic function? As we can see, our vertex is the lowest point because our parabola opens up. And since that's the lowest point, our quadratic function exists from this vertex point going upwards. We're referring to the y values or the vertical values. So the function exists from y is equal to 2 to positive infinity. Okay? So y is greater than or equal to 2, or from positive 2 up to positive infinity. How about the maximum? Do we have a maximum here? It doesn't exist. Because our parabola opens up, it will extend upwards infinitely. However, for our minimum, yes, the minimum value is 2.